Hello everybody. Today I am beginning a course on basic electrical engineering. There is a series of lectures. I will discuss the basic electrical circuit, circuit parameters, DC networks theorem, AC fundamental and different type of machines like motor, generator and transformer. In this first lectures is an introductory class.
The lecture will cover electric circuit, linear and nonlinear circuit, bilateral and unilateral circuit, dependent and independent source, active and passive elements. Circuit parameters. The basic primary electrical circuit parameters are resistance, inductance, capacitance, current and voltage. The other parameters are work, power, energy and torque. Voltage. Electrical potential at a point in an electric field is defined as the amount of work to be done to bring a unit positive charge from infinity to that point. Here, infinity is a reference where electric potential is considered zero. Now, electron being negatively charged, less work is to be done to bring a unit positive charge from infinity to a point with high electron concentration with respect to the low electron concentration. By definition, less work means less potential and high work means high potential. It can be concluding that electrons flows from low potential to high potential. Similarly, the potential difference between 2 points is defined as the work required to be done for bringing a unit positive charge from one point to another point. The familiar term voltage is the common name for electric potential difference. Keep in mind that whenever a voltage is quoted, it is understood to be the potential difference between 2 points. For examples, every battery has 2 terminals and its voltage is the potential difference between them. More fundamentally, the point you choose to be 0 volts is arbitrary. This is analogous to the fact that gravitational potential energy has an arbitrary zero, such as sea level. Electric current. An electric current is said to exist when there is a net flow of electronic charge through a region. As already discussed that electron flows from low potential to high potential. To make this fit with the general theory that everything goes from high to low potential, we introduce current that flows from high potential to low potential and say that it has direction opposite to that of flow of electrons. Electric charge is carried by charged particles. So, an electric current is a flow of charged particles. The moving particles are called charge carriers, and in different conductors may be different type of particles. In electric circuits, the charge carriers are often electrons moving through a wire. In an electrolyte, the charge carriers are ions, and in an ionized gas are ions and electrons. Negative terminal means excess of electrons, and positive terminal means deficiency of electrons. The SI units of electric current is the amperes. Ohm's law. It states that the current through a conductor between 2 points is proportional to the potential difference across the point. It is assumed that the physical conditions do not change. That means pressure, temperature, and cross-sectional area are constant. The equation is V proportional I. Here proportionality constant is R, and this is the resistance of the path. The mathematical equation is I equal to V by R. Resistance. Resistance is the opposition that a substance offers to the flow of electric currents. When an electric current of 1 amperes passes through a components across which a potential difference of 1 volt exists, then the resistance of that component is 1 ohm. Loss of resistance. The resistance of conductor is directly proportional to the length of conductor. Then we can write R proportional L. The resistance of a substance is inversely proportional to the cross-sectional area of the substance. Combine these two equations, we have R equal to rho L by A, where rho is the resistivity of the material. It is a material property, and L is the length of the conductor, and cross-sectional area of the conductor is A. Electrical circuit. An electrical circuit is a path in which electron flows from a voltage and current source. An electrical circuit is composed of individual electrical components such as resistor, capacitor, and inductors, connected by a conductive wires through which electric current can flow. Here the basic electrical circuit is shown. It consists of a source of energy, a load which utilizes the energy, and two conductors connecting the source and the load to transfer the energy. The terminal of the source through which the current leaves is called the positive terminals, and the terminal through which the current enters the source is called the negative terminals. Linear circuit. A linear circuit is a special system whose output is directly or linearly proportional to input. Example, an electrical circuit with conductor. Here power source is connected with resistors R. If there is a regulating system, then it can be observed that current through the resistors is proportional to the supply voltage. Hence, the circuit is said to be linear. Non-linear circuit. A nonlinear circuit is an electric circuit whose parameters are varied with respect to current and voltage. In other words, an electric circuit in which circuit parameters like resistance, inductance, capacitance, waveform, frequency is not constant is called nonlinear circuit. Example, an electrical circuit consists of diode, transistor and other semiconductor device. A nonlinear circuit can be explained by this figure. In this figure, a PN junction diode is connected between resistors and supply battery. P end of the diode is connected with positive terminal of the battery. So the diode is in forward bias. Here the measure current through the resistor is not linear. So the circuit is said to be nonlinear circuit. The bilateral circuits allows the current flow in both directions. The transmission line is the main example of the bilateral circuit because if you give power supply from any direction, the circuit properties remains constant. Unilateral circuit. In unilateral circuit, when the circuit property change at the same time, direction of supply voltage and current also are changed. The diode rectifier is the main example of the unilateral circuit because it does not perform the rectification in both direction of supply. Example, an electrical circuit consists of diode, transistors and other semiconductor device. A brief circuit diagram with PN junction diode as shown in this figure. VI characteristics is shown in previous diagram for forward bias only. In case of reverse bias, the VI characteristics is completely different as shown in figure. Here positive voltage indicated forward bias and negative voltage indicated a reverse bias. As per definition, this circuit is said to be non-linear. Source. An electric circuit is alive if there is power source. Power sources are either voltage or current. There are two types of electrical sources, being the voltage source and the current source. The current source is usually less common in circuit than the voltage source, but both are used and can be regarded as complement of each other. Based on the relation between output and the circuit parameters, there are two types of source, independent source and dependent source. The independent and dependent source means whether the voltage or current source are either depending upon some other source or they are acting independently. Independent source are voltage source and current source, and dependent source are voltage control current source, current control voltage source, current control current source. Independent source. Strength of voltage or current is not changed by any variation in the connected network. The source is said to be either independent voltage or independent current source. In this, the value of voltage or current is fixed and is not adjustable. Voltage source. An ideal voltage source that has zero initial resistance is known as an independent voltage source. But in practical case, there is no zero internal resistance. A voltage source such as battery or generator provides a potential difference between 2 points within an electrical circuit, allowing current to flow around it. There is no as such example of ideal voltage source, but a lead acid battery or a dry cell can be considered an example when the current drawn is below a certain limit. Current source. An ideal current source is a two-terminal circuit element which supplies the same current to any load resistance connected across each terminal. It is clear that this type of current source is not practically possible. There are also some current sources encountered in our everyday life, such as photoelectric cell, metadine generator, etc. Dependent source. It is a voltage source or a current source whose output value depends on a voltage or current elsewhere in the network. Dependent sources are not necessarily linear. A dependent voltage source is indicated with a diamond shape and is used as equivalent electrical sources for many electronics devices such as transistor and operational amplifier. This figure is independent voltage source and this is independent current source, dependent voltage source and dependent current source. Energy handling element. There are two types of energy handling elements: active elements, passive elements. An active element is one that is capable of continuously supplying energy to a circuit, such as a battery, a generator, an operational amplifier, etc. Active elements have the ability to electrically control electron flow, that is, the flow of charge. All electronic circuits must contain at least one active component. Transistors are not generating power, but it is able to amplifying the power of a signal. So it is also an active component. Common example of active components: voltage source, current source, generators, diode such as Zener diodes, photodiodes, LED, etc. A passive element, on the other hand, is physically element such as resistors, capacitors, inductors, etc., which cannot generate electrical energy by themselves, but only receive energy, which it can either dissipate or absorb. As the name passive suggests, passive devices do not provide gain or amplification. Passive components cannot amplify, oscillate, or generate an electrical signal. When transformer step up or step down voltage, power and energy remain the same on primary and secondary side, as energy is not actually being amplified. A transformer is classified as a passive element. Common examples of passive components: resistors, inductors, capacitors, and transformer.
Next lectures are coming soon for more discussion. Please follow the lectures. Thank you.